My name is Nithya Ramamurthy, and my presentation is on the analysis of the standing versus seated workstations. You will find that most companies in the United States and Europe provide workstation tables where the workers either stand or sit in a chair to complete their tasks. However, in many parts of Asia, Africa, and South America, it is common to find workers who prefer to use the floor as their workstation. This project will specifically look at work done by artists and craftsmen. The goal of the study was to determine whether a standing table workstation or a seated floor workstation is ergonomically more beneficial for the health and efficiency of the workers. The objectives were to maximize the reach limits, increase productivity, and identify points of fatigue. For the methods, there was one test subject used, which was a female of the 5% height stature. There were two workstations provided, one standing at a table and one seated on the floor. The standing table workstation featured a table that was 1.2 meters in breadth, 0.6 meters in depth, and 0.7 meters in height. And the seated floor station featured 7.2 square meters of workspace. There were three key tasks asked of the subject, which was braiding a string bracelet, sorting beads, and stringing the beads onto the bracelet. And each task was completed a total of 3 times per workstation. There were 3 tools used to collect and analyze the findings. The first was SketchUp, which was used to evaluate the reach limits at both the standing and seated workstations. The second was MODAPS, which was used to calculate the times for each task as well as evaluate the productivity of the worker. And the third was 3D SSPP, which is a software that helps evaluate points of fatigue. It helped calculate % maximum voluntary contraction, which is the amount of tension the muscles experience to generate and hold a certain position. The SSPP was also used to find the time until the hand and forearm muscles experienced pain. For SketchUp, it was found that a female of the 5th percentile stature has an arm reach of 0.477 meters. Based on this reach, 1.2 meters by 0.123 meters of the workstation cannot be reached unless the worker leans forward and stretches. And this applies to both the seated and standing workstations. However, it is easier to stretch at a standing workstation because the body's weight can be shifted from one leg to another. The seated workstation, however, is unable to utilize the lower body to assist in leaning forward. Through MODAPS, it was observed that the standing workstation experienced less number of mods and shorter completion times. When developing the MODAPS code for the tasks, the standing tasks utilized M3 movements of the elbow. And this is because the worker was able to place one leg in front of the other and lean forward to prevent constant back and forth movements. The seated task, however, required M4 movements, which uses the whole arm. With 3D SSPP, the points of fatigue were found. The 3 models on this slide represent the postures for braiding, sorting, and stringing while standing at the workstation. Looking at the % maximum voluntary contraction of the 3 tasks, it was found that sorting required the most muscle tension. Here are the 3 models that show the postures of braiding, sorting, and stringing while sitting at the floor workstation. Similar to the standing station, sorting required the most muscle tension. The % maximum voluntary contraction for the seated tasks were roughly 20% higher than the percentages for the standing tasks. And this can be attributed to the exertion and stretching that's frequently required while sitting. The time the worker was able to endure the seated tasks ranged between 46 and 54 seconds, which is approximately half the amount of time that was required for the standing tasks. Based on the results from SketchUp, MODAPS, and 3D SSPP, I would recommend the use of a standing workstation in order to complete tasks similar to the ones in this project. The standing workstation was able to maximize the reach limits and allow the use of legs in order to stretch and lean forward. The standing workstation also increased productivity by roughly 15% as seen by the MODAPS analysis, and utilized the elbow movements as opposed to whole arm movements during the tasks. Because the time that it required to endure the task before experiencing pain was longer, the need to stop and rest was reduced by 45%. There were a few limitations on this project. The first being that there was only one test subject available, so the sample size was rather small to make large conclusions. There were a limited number of 3 trials per task for each workstation due to the time constraints of this project. This project is only applicable to the 5th percentile female stature. For future work, I would recommend to analyze the seated table workstation and see how that compares to a standing table workstation and the seated floor workstation. Also, other tasks could be looked at, such as painting, drawing, sculpting, and other artistic tasks.